Hello again everyone, this is Mr. Hoy. In this video I'm going to be going through a lot because what it means to make a table of coordinates is that you're making a list of different points that all exist on a parabola, and when you're watching this video I want you to keep in mind the question that we're looking at right now regarding just constructing the table, but I also want you to keep in mind how we're going to look at all of these points and how we might apply them to future questions. It's the kind of question you definitely want to write down. You're definitely going to want this table handy. If you're jotting this down on paper, it'll make this upcoming question as well as the next couple of questions much easier because you simply have to locate the values on your table and then make those selections in the assignment. So, how do we construct a table of values? The first thing we want to do is take our vertex from the previous question. So if you watch the previous video, look at the previous example, we determined the vertex to be 4, 2. If you're not sure how we got to 4, 2, go back to that video, watch that again, make sure you understand how we got there because that will be the center of our table that we look to create here. So I put this coordinate here. I have a few points above, a few points below. It doesn't need to be the exact center, but you want to remember that we're talking about a parabola. That's a curve that goes upward or downward where the vertex is the middle. So just like the vertex is the middle of the graph, the vertex should be the middle of our table of coordinates here. So 4, 2 is in the middle. What you want to do then is pick the nearest coordinates, nearest integer coordinate. So I'm going to choose 3. 3 is the same distance from 4 as 5 is, so I show the work here on how to determine the coordinate that has an x value of 3, but I want you to keep in mind that you're going to get a reflection here, and these points will then match up with the ones I found up there. So here we've got 3 as the x value. We're going to plug that into this equation right there for the x, right there again for the other x value, and you'll see here I just squared the 3. I multiply the 3 by 4 over here. We simplify a little bit further. Negative 1/2 times 9 is negative 4.5. And then we just combine some like terms here. And we get positive 1/2 or positive 1.5. So what this means is when I plug in 3 for x, the result is 1.5. If I plug in 2 for x, as I did down here in red, plug in 2, you square the 2, and you'll eventually multiply the 2 by this 4 as well. Here the work is shown for that. You'll simplify this further, and you'll get down to a 0 value there. That means the coordinate 2, 0 exists on the parabola. Keep going up this table. The next value I'm going to substitute is 1. I plug in 1, I square that. Now be careful with this one because you're going to have a 1 times a negative 1/2. That leaves that as negative 1/2, and it leads to a fractional or decimal answer again, just like it did here. You'll get 1, negative 2.5 if you simplify that correctly. Lastly, I'm going to plug in 0. And the reason that I have a few more points on this side of the vertex than I have on the other side is you always want to do as many coordinates as needed to get to 0. So you're going to need to plug in 0 for x at some point. That could mean going backward as we did here from 4 to 3 to 2 to 1 to 0. But it could also mean if you have a negative number going up to 0. You always want to substitute 0 at some point in time. Here I substituted 0. 0 squared is obviously 0. This is probably the easiest of the 4 questions to do in your head if you're working through this. 0 is going to create a 0 term here and here, and it's just going to leave you with this c value of negative 6. And really, if you have a standard form equation as we do here, plugging in 0 for x will always get you back to your c value as the result of that. So you can kind of speed that process up a little bit by identifying you're plugging in 0 and just taking that c value and putting that here in your table. So now we've created this side of the table. I mentioned before it's a reflection, so you've got the same values here so long as these values are the same distance from the vertex as their reflective pair. So 4 again is 1 away from 5, it's 1 away from 3. It's 2 away from 2, it's 2 away from 6. It's 3 away from 1, it's 3 away from 7. If I wanted to continue this table, I could plug in 8 right here. That would lead to a value of negative 6 down there. But again, as you're working through these questions, the most important thing is that you have a table of values to use in the subsequent problems that I'll discuss in a moment. So if you're doing a question other than this one, make sure you have an accurate table of values before continuing on to the next few questions.